Thanks for tuning in. Today I'm going to talk about a newly compiled North American tree ring fire scar network. And I'd like to thank particularly Chris Gitterman, co-author, and then more than 100 more additional co-authors for this extensive effort listed here. So as we all know, fire is increasing in size and severity across much of Western North America. And this not only affects people locally, but also smoke effects for public health locally and as well as regionally, and even as far as Washington, D.C., and even affecting people across the ocean in Europe. So this isn't just a local problem. This is something that's going to begin to affect everyone. And so with these increases in fire, people start to wonder, well, are these the biggest we've ever seen? And we have to remember a lot of the records we've seen and use and analyze are relatively short, often from the Landsat era back to the mid-1980s. And so a longer perspective is very important to understand the past effects of fire on ecosystems as well as the future. And so tree ring fire scars provide that perspective with records going back centuries to millennia in terms of giant sequoias. Here's some photographs of fire scars in the field from multiple species, from red pine to oaks, from Canada to Mexico. And these records are quite remarkable and very important for understanding the future of fire. So trees are great because we can scale up from individual trees to landscapes. This one here, Jemez Mountains in northern New Mexico, all the way to North America. And so they provide opportunities for cross-scale analyses. So the current network that we've recently compiled includes greater than 2,500 tree ring fire scar sites, more than 35,000 trees, quite a wide range in latitude from southern Mexico to northern Alaska, range in elevation from sea level to greater than 4,000 meters, and has a temporal depth that goes back over 1,000 BC to the present. In this talk, we'll analyze multiple components of the network, including the geography, vegetation, spatiotemporal patterns, topography, climate, and humans to develop hypotheses and provide a roadmap for future analyses. So starting with geography, there's good spatial coverage, but there's clearly differences in density in sites across North America and by regions. Many reasons for this, including just availability of trees that have fire scars and historical fire regimes, but also including things like human land use and logging that have removed records and burning, as well as other things like just the length of research stations in certain areas. There's high densities near places where people have been doing tree ring fire scar research for a long time, including in the southwestern US. In terms of vegetation, pretty good spatial coverage. On the left there, these are forests of North America, both gymnosperm and angiosperm. And on the right, you're looking at ecoregions, and there's tree ring fire scars in 13 out of the 15 ecoregions across North America. So pretty good spatial coverage, but of course some gaps and opportunities to fill in, looking at it from different perspectives. There are 90 tree species across North America that have tree ring fire scars. And the importance varies by ecoregion. Here are the different pie charts showing proportion of species in any ecoregion. Pine is the dominant genus for tree ring fire scars, but there are also other conifer genus as well, and angiosperms, including oak, is a very important genus like in the Great Plains. And so regionally, depending on the tree species, that's where most of the records will come from and may have variable importance. Spatially and temporally, in the top, there are maps of the record from the upper right is all the records, and then going back to 1700, you can see in that the middle right map, there are pretty good records going back to 1700, so pretty good spatial coverage. And then the far left is back to the year 1500. And so the oldest records are primarily in the Western US as of now, but there's potential to develop more. If you look on the bottom, you can start to see some patterns emerging. That's the last fire date. And so start to see that peak in last fire date circa 1900 in some regions, representative of fire exclusion, and then other regions are still burning out to the present. We'll talk a little bit more about that. But good opportunities with good sample depth to provide some multi-century perspective on modern fires. In terms of topography, we used a state space analysis where we used the North American forest presented earlier, and then took topographic variables and compared the portion of those variables to the fire scar network. And so in the upper right, the background is the lighter green, and the black dots are the fire scar network. And so in terms of elevation, there is a bit of an undersampling at the lowest elevations. If you look at on the far right, the green shading well exceeds the gray shading in the distribution curves. And so opportunities to give more fire scar sites at those lowest elevations, and also in terms of the forests that are in the flattest context. And so some of the coastal plain areas, and then maybe up in northern North America, in the flatter, lower elevation forests, where there's more opportunity to collect more fire scars. So depending on which variable you use, you can use these analyses to try and determine gaps and for future sampling. In the bottom right, we looked at slope aspect. And again, the background forest across North America are the green, and the black are the fire scar samples. And you can see the black bars protruding beyond the green, so an oversampling in the southern aspects, the drier aspects, warmer, drier aspects, and maybe an undersampling in the northern aspects of North American forests. So both talking about representing process and also potential for future sampling to try and look at some other slope and aspects. And then these vary by ecoregion, which is included in the paper, but not talked about here. So for climate, we also used a similar state space approach, where we took precipitation and temperature for forests across North America. So that's the blue shaded background. In all of these, all of the figure panels in the upper left is for all of North America. And then the black convex holes and the black dots in all the panels are the tree ring fire scar network. So comparison of background state space climate to the fire scar network to look at patterns and maybe over and under sampling. And then the other data set included on this figure is the red polygon, which includes the 95th percentile of modern fires. And so we developed a North American fire atlas to develop that. And so in the upper left panel, looking across the whole of North America, there's relatively good correspondence between the red polygon, which is the modern fires, and the black, which is historical from the tree ring fire scar network. Pretty good overlap, except in the warmest climates, where the modern fires seem to be burning, but we don't have records of those from the tree ring fire scar network. So this could be representative of under-over sampling, or possibly changing fire regimes. More to be determined on that. And then looking at the individual ecoregions on the right, there's various things that are interesting, but bring your attention to the upper central panel of the northern forest, where the modern fires, the red circle, are burning in kind of the lower left portion of the climate state space, and historical fires in the black show extent beyond that. And so possibly representing potential for modern fires to extend farther into the climate and or geographic state space in that ecoregion. And lots of other possibilities, interesting patterns, again, to direct some future research related to fire climate. And the last component that we assessed was humans. And of course, humans have influenced fire regimes for a long time in many places across North America. In the upper left panel are a number of mapped indigenous territories from an online database representing just potential for long human occupation and long potential human influence and varied human influence on fires across the continent. Upper right panel, panel B, is the estimated population pre-European contact. And so obviously very dense populations in southern part of the continent, down into Mexico and in some of the coastal regions, and less dense in other areas. So again, these can be used to frame hypotheses for human influence through space and time. And then comparison with panel C, which is estimate of modern population. And so clearly on the East Coast, people have moved quite extensively across the eastern part of the US and in various places in the West. But again, good opportunities to look at modern versus historical influences on fires. Panel D is an estimate of approximate timing of European influence on the landscapes, and potentially, again, to frame hypotheses on the timing of potential non-native influences, human influences on fire regimes. And so again, variability with the first European settlements in the South, in Mexico, back to early circa 1600, and then later influences in the northern part of the continent. So again, possibilities to look at human influences through time with the Treating Fire Scar records. And the last panel, panel E, is the median last fire scar date. So again, coarse representation of when fire regimes may have been disrupted. And the dark blue are circa 1900 or late 1800s, and the yellow are much later into the 1900s last fire scar date. And so looking across the Arizona, the Mexico, Arizona-New Mexico border at the southern part of the US, you can see a change from the blue to the yellow, which indicates a difference in last fire date and influences of humans on fire regimes. We know in the southwestern US, there's heavily influenced by fire exclusion. Most fire regimes stopped late 1900s, circa 1900. And in Mexico, many fire regimes continue, as in other parts, some other parts of the US, like the Southeast. But this, again, representative of modern human influence on fire regimes, and so can frame future questions and hypotheses of human influences. Thank you for this. We have our many future directions. Hope to see much more with this data set, including regional to continental fire climate and human vegetation relationships, modern versus historical fire regimes, scaling properties, and maybe calibration validation of gridded fire frequency models, including from the land fire data set. And we're happy and open to more contributions and collaborations with these data to answer other questions about fire. Thank you for your time.